Good afternoon. It's a pleasure to be here today. Today I will describe a research trajectory that has inspired my work for quite some time now. I will speak about the integration of technology in habitats and build spaces designed for habitation. And I will share work and observations that will point to the emergence of a field where interaction design, physical computing, and building engineering practices as a whole are merging. The field that I'm describing is space itself, this frontier, this new trajectory, that are built to mediate physical digital interactions in space. It serves a purpose to frame our conversation with a general notion of networked environments themselves, whose characteristics is really unique, the environments that I've been passionate about studying. These are environments whose fundamental design characteristics is the integration of technology. Technology is so intrinsic to them that without technology, these spaces would not make sense. And without integration of technology in space, the technologies would underperform. So whether they're more common environments that are familiar to us or extreme, like the ISS, they all share the common denominator of being inhabited by lead users, which, if you're interested in designing intelligent environments, are actually very important for you. These users manifest design requirements today that will only be familiar for users in the future. So recently I was asked to speak about the design of space habitats. I will only reference some of these spaces today because they're useful insofar as they demonstrate some characteristics to areas of work and design that are actually relevant for other networked environments here on Earth. So whether we're talking about architecture hardware, what are the network components that actually create the space itself, or the user operations that are in fact supported by those components. What happens in the space? What are the objectives in that environment? We're actually seeing that these environments are designed as an inhabitable technology. This is a beautiful office, obviously, in the ISS. And the primary function of these inhabitable technologies is to help the user get something done, to actually do a job in the space. So you actually can talk about manufacturing of space as a product itself, because these spaces, in fact, are designed as networked objects that are altogether creating the environment, and as such, they're programmable. So the research question for me has always been, what happens when users of a technology become its inhabitants? And in this specific case, what we're looking at, I will use two examples in bodies of work. The first example that I will share is an actual research, a design collaboration between a team at Microsoft Office Labs called the Envisioning Team and the ideation studio at Herman Miller in the R&D department. We actually had, from our perspective, quite an interest in understanding performance in space. The objective of this space was to enable these users to manifest in physical environment their own software vision of the future. And what we found out is that although we're coming at it from very different angles, so from manufacturing of software and manufacturing of physical products, at our front end of R&D, we were actually looking at a space of convergence, where physical and digital considerations, when we were looking at the space itself, were actually parallel. We shared a vision. So in my work at Herman Miller, I've often used a programmable platform. It is a tool in itself that was designed based on principles that saw in the future environments where the states that they would describe were environments where everything would be recognized as both physical and digital, and where users were so important to the space that they would actually be considered its co-designers. From a technical perspective, this is a programmable grid that is a programmable power delivery infrastructure system. It is composed of a network of distributed sensors and actuators in the space that can be controlled by users through either a programming gateway or a hand user interface. But what it did for me is that it allowed us to separate the building systems from what would actually happen below, which was free reign for users who are advanced programmers but had never really built a space before. So this was an Office Labs expression of what an environment where software would continuously rotate and be shifted all around, and therefore the environment would have to follow as the prototypes rotated from one different output location to another one. And so what we saw is that the application spaces below in this environment, as these users express their own performance attributes, were spaces where software content was actually delivered at an architectural scale, which actually manifested their own work behaviors in a sense that they would be familiar with working on vertical work surfaces, because that's what we all do when we brainstorm, as well as they would have a tendency as lead users to engage with natural user interfaces that in a prototypical fashion, like here, would actually seamlessly merge digital content from elements in the space, such as walls or even furniture-like objects or portable devices, etc. or even analog elements in the space, like in this case, a wall, a programmable wall, that would act as an actuator when arriving at a certain location and triggering a reaction in the space, like a projector coming on and therefore becoming real estate for software interaction on top of just being space division. Or even spaces is still in this lab where natural elements such as this green wall, which of course are triggered by sensors and humidity and motion detectors, would actually create a certain kind of experience in the space that was familiar to them. But from a programming perspective, what I was interested in was giving the users the tools to actually affect the very properties of the space itself. Again, the space is a technology. So a space to feel different when it was inhabited by 2 or 3 users, or 30, as we can see in the space over here. So what you're seeing here is, in fact, some programmable fruited wall panels that were designed with Herman Associates in this project, which allowed us to control a property of the space, which was opacity. So triggered through relays here in a linear algorithm, we were able to create a pattern that would convey a different kind of emotion in the space, as well very tactically, as I spoke before, user operations from an operations perspective would allow us to control the perception of the depth of space. So when your peripheral vision is closed, you can focus on the piece of software prototype that you're examining, and when it's open, the space feels bigger. Therefore, you have a very different relationship with the physical environment around you. So what you're seeing here, the second, I have to go through this quickly, but the second user content that I'm looking at is in fact environments like the Georgia Tech Library and some prototype spaces where the very basic building blocks of space are programmable and interactive. So walls that communicate based on sensor data that's in the chairs, whether a room is full or empty. Ceiling elements that could be articulated to create temporal use spaces for a meeting or for a brainstorming session and focused around technology and disappear. Or environments that would react to your checking into an office and would actually help you get to your next meeting just because the space itself communicates something about information and data that's associated to your profile. Or manipulating a wall to create a space where you want to hide out and communicate to others in the room that you just don't want to be disturbed. So when these tools were given to these students, which for me it still remains probably my favorite project at the Georgia Tech Library renovation, they simply engaged. They simply felt that these were natural tools for the way they worked and the way they studied and the way they used their laptops and the way they collaborated. And effectively, the idea came as an open source idea that looked at space itself as an open source platform. So values of openness, sharing, collaboration, and engagement, and somebody making their space were actually encouraged and recognized. So this is what this space looked like at 2 a.m. The students had reprogrammed the lights, they had moved the furniture, they had moved the walls, and the space had to meet performance requirements, what they wanted this space to do, which was to feel different than the morning after finals, when everybody had to gather together and just sort of hang out in the space, which became a very, very, very popular space. So at the end, I will just leave with, I asked the question, as I myself was reflecting on this body of work, which has been a 5-year project for me, what happens? What happens when technology becomes an intrinsic component of the environment? And I think I've concluded that, environments communicate, in fact, can communicate something about you and about your brand, about your values, about what is important to you, and certainly, as you see, they can perform a function. And in this case, lead users, whether they were corporate users or students or even startup users in other projects, actually engage and were able to connect with an environment that was interactive and programmable because it's a natural extension of the way they see, the way they work anyways, to technology tools. So at the very end, I think while the real estate and building and construction industry as a whole is actually quite fragmented and has a very different understanding of technology, therefore various different stakeholders. Technology in buildings is really all around us. We just don't really see it in most cases. And in some cases, you actually can't talk about legitimately of intelligent buildings. But technology in itself is a design medium. It's a medium that has, therefore, an intrinsic logic. And understanding that logic allows you to see patterns and, to a certain degree, to almost accurately predict future developments of that specific medium itself. So what I have shared today are undoubtedly fringe edge-like conditions. These environments are far from mainstream, and they're very small contributions, among others that are being done out there, to try to understand what the effects of technology for users and for the environments are alike. But I do believe that they, without a doubt, indicate and tell us something about the way future environments will be for many, not just for a few. So I find that to be a really encouraging proposition, and I find it to be an exciting new field of exploration in technology. Thank you.